Hello, ladies and gentlemen. It is AP Statistics 6.1. We're going to go fast and furious until the finish line. We have about 4 months left. AP exams coming up. We got to get through Chapter 11 at least. We're going to have so much fun. I am under the weather, and so I'm going to be teaching you via video today. And 6.1 is continuing on in probability. So if you liked last chapter on the big book probability, you will love chapter 6. Actually, probably not. And most of you guys are like, I didn't like probability in the first place. Well, too bad. Okay, chapter 6 is listing out the whole distribution, though, basically, of probability. What's all the ways something could happen. So we're going to start off here and kind of talk about what is a probability distribution. Well, probability distribution, I'm just going to skip right down here, okay, is all the ways something can happen. Now, last chapter we talked about what's the probability this and this could happen, or this could happen. But now I want to know the event, all the ways events could happen, okay? So, and, or, maybes, okay? So, for instance, like football. What's the possibility they win? Well, you list the probability of them winning. What's the probability they lose? And then there's one more section. They could tie, right? So what's the probability of them tying? Listing out all three would be the probability distribution. It shows all the possible ways. Okay? Water. My throat has been really bad. And I'm just not feeling good, guys. It's a cold, not a flu. For those of you that I know what you're thinking. It's a cold, not a flu. Okay? I know what you're thinking. Anyways, the probability distribution. All right, so here's an event. All right, consider tossing a fair coin 3 times. All right, okay, 3 times. So, what's the probability I get heads? Well, there's a chance I could get goose egg, right? And how many ways could I get no heads? Well, there'd be 3 ways, right? I could get, I got to get all 3 tails. So there's only one way, 1 out of 8, to get a goose egg. What if I want 1 head? Well, there's 3 ways to get a head. Notice this is called my sampling space here. All the different ways events can happen. So there's 3 out of 8 ways. What if I wanted 2 heads? Well, there'd be 3 out of 8 to get 2 heads. And then if I wanted all 3 to be heads, well, there's only 1 in 8 chance. This is the probability distribution. Now, if I wanted to graph this, I'm going to just take this out, blow it up. This is what the graph would look like. I don't know. Can you guys see that? Okay. Probability gets 0 would be a 1/8. Right. This would be a normal curve. It looks roughly normal, symmetric, definitely. Will all probability distributions be like this? And the answer is no. They won't all be like this. Like rolling a dice would be, you'll see 7 is going to be the peak. You're right, rolling a 7 with 2 dice is the peak. And then it goes back down. And obviously the ones that are the most rare are your double 1s and your double 6s. Which would be 12s and 2s, but 7s are the most common way to roll dice. But you guys all know that, because you're smart. I gotta move. We only got 11 minutes. We haven't even done any math. Alright, so we got this thing called discrete, and we have continuous, alright? So, let me get out my pen. Today we're going to be talking about discrete, but I think on Thursday we're going to be talking about continuous. But discrete is basically numbers that we can count for sure. Okay? Like brothers. How many brothers you got? Either 1, 2, 3, 4, 0, right? You can't have 1.2975 brothers, right? Okay? So discrete would be where you're going to get almost, I don't want to say whole numbers, but they're kind of like whole numbers. You're not going to get too weird of numbers. Continuous would be like your weight. Do you really weigh 150 pounds or do you weigh 150.00009? Huh? Right? Okay. So we're going to talk about continuous. That gets into a whole lot of other fun stuff. And those in calculus probably have heard Blake Budrow talking about continuous. And how we are never a certain weight before. But we'll get into that later. Okay. Alright, so we're going to talk about discrete, which are like ones we can actually list out all the ways it can happen, right? So, a discrete random variable takes a fixed set of possible values and basically lists out all the probability. Alright, now we have discussed this before, and just so you're aware, every number, every probability has to be between 0 and 1. You can't have something over 100% possible, right? You can't have something less than 0% chance. Every outcome has to be between 0 and 1. And then all the sum of everything needs to add up to 1. So adding up all of the probabilities, you should get, adding up the whole distribution, you should get 1. Alright? So let's take a gander. Let's go back. Okay, so for instance, are all of these... Is that between 0 and 1? Yep. 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 Then add them together. Do I get 1 if I add them all together? And sure enough, I do. Okay. So, that's just testing out your probabilities. Okay. So, here we go. Apgar tests. Alright, I just want you to take a moment and text your parents. Go for it. Text your parents. Ask them, what's my Apgar score? It's your very first test in life. Your Apgar test. In fact, within the first couple minutes of being born, you are given a test. It's called the Apgar score. And you get a scale from 0 to 10. 0 to 10. And that tells you how healthy of a baby you are. Now, they have different things like skin color, all that kind of good stuff. You know, are you pale? How's your breathing? Reflexes, kind of all that kind of stuff. They test you within those first couple minutes. And only really good parents know your Apgar score. Okay, so if your parents don't know what your Apgar score is, tell them Mr. Sheeby. No, I'm kidding. I'm joking. In fact, I asked my wife, and she doesn't even remember what Graham's Apgar score was, but I'm pretty sure it was like an 8. I think it was like an 8. 8 out of 10. He wasn't perfect because he wasn't, like, crying. I don't know. So I don't think he had the right color to himself. Anyways, alright. We're going to move on. Anyways, what Apgar scores are typical? To find out, researchers recorded the Apgar scores of over 2 million newborn babies. Imagine selecting one of these newborns at random. Alright, X would be, alright. So, here is what they got for scores for these 2 million babies. Alright, now a 0 means those babies are very at risk. So, people who are premature, like I had some people that I think were at like a 1. I could name them because I still remember them, but you'll have to let me know what your Apgar scores are. But I had people in this class before who have an Apgar score like a 1, and they were preemies. Okay, anyways, it's very low chances that these are your Apgar scores, right? Up here though, you have a 32% chance of getting an 8. Okay, which I'm pretty sure that's kind of where Graham is. And you have a 43% chance of getting a 9. Alright, so show the probability distribution is legit. Is this legit? Alright, well, first of all, what you should do on your papers is list off, and feel free to pause the video if you need to, is everything between 0 and 1. Nothing's less than 0. Nothing's over 1. Cool. Nothing's less than 0, nothing's over 1. Alright. Now the next thing you need to do is you need to add them all up and make sure they add up to 100%. Now, for the sake of time, all probabilities are between 0 and 1, and they do add up to 1. This is legit. distribution. It's legit. Man, I wish I had more than 15 minutes. We're already 10 minutes through, and I feel like I haven't even gotten to anything yet. All right. Then, next question says, make a histogram of the probability distribution. Describe what you see. All right. So, for the sake of time, I don't want to show my other answer here. But here is what I got when I made my distribution. Now, once again, I said, are they all normal? No, because Apgar scores are not normal. And if you were to graph this whole plot out, it would look something like that. In fact, I would say it's left skewed. And it suggests that randomly selected newborns will have an Apgar score at the high end of the scale. There's a small chance of getting a baby with a score of 5 or lower, right? It seems like most scores are up there. I'll be describing what I see. Otherwise, other ways I could describe a shape would be shape, center, spread, outliers. Okay. And the last question says, Apgar scores of 7 or higher indicate a healthy baby. What is the probability, that's what that means, P, what's the probability of a baby getting greater than 7? It's got to be bigger than or equal to 7. Now you notice this equal to is under there, which means I include the 7. So anything 7 or above is a success. So basically I'm going to add these guys together. And by adding them, alright, I should get my results for C, right? Now remember, if this didn't have this, right? If it didn't have that equals underneath, I wouldn't include the 7 because it would be just, it has to be greater than 7, which would be 8. I'm going to run out of my water. Well, I got 3 minutes left. Holy moly. Okay, if you do that, here's your answer. You have about 0.908. We'd have about a 91% chance of randomly choosing a healthy baby. 3 more minutes. Woo! All right. Last thing. How do we find mean? I love this. Guys, just remember this. Whoop, whoop. Oh, let's go like this. Whoop, whoop. Okay, can you guys do that all? Everybody in class, you ready? Go whoop, whoop. All right, cool. When analyzing discrete, we can actually figure out the mean. Okay? Now, I want everybody to highlight this or write it in their notes. The mean is called your expected value. What would we expect most people to get? Right? Okay? What would it be? All right? So, how can we do this? Well, there's this insanely complicated formula right here. Right? For mean. Or you can just do what I do. You guys ready? I don't like formulas. What do? Guys, I go like this. Whoop, whoop. Okay? My wife likes it. She's laughing here. Oh, my son's wondering why I'm talking to myself. It's alright, Daddy's just gone senile. Okay. Whoop, whoop. Alright. Okay. So, here's what we do. You multiply down. Alright? So 0 times 0.1 is 0. Multiply down. 1 times 0.06 is 0.06. Right? You guys getting the drift here? Then you multiply down. 2 times that should be 0.014. 3 times this should be 0.024. By the way, I'm writing with the mouse. Okay. Anyways, so you get my drift. This is how means work. You multiply down, and then you add all of them up. Okay? So notice I'm multiplying down. I'm running out of time. But I'll multiply down, and then I'll add across. If you do this, feel free, pause it up. Okay, if you do this and multiply down, add across, you should get an 8.128. What does this mean? We should expect most babies to get about an 8. That is the expected Apgar score, is an 8. Alright, that's what that means. Okay, So what I want you guys to do is don't do anything with standard deviation. We'll talk about that later. Answer these other questions.